Thank you for attending GIRD Systems presentation on the technology we've developed for the Navy under topic N68335-23-C-0162 Wideband Interference Suppression for Dynamic Range Optimization, or WISDOM for short. This is an overview of the WISDOM SBIR program, and we'll be presenting how our technology addresses the needs of the Navy, our approach to a solution, its status, and an overview of applications where technology transition is being sought. GIRD Systems is a small business in Cincinnati, Ohio, that develops advanced signal processing solutions for communication systems that range from novel anti-jam waveforms to the signal processing that enables communications in congested and contested environments. Our staff has experience designing advanced military waveforms for the DoD. And just this year, we are transitioning one of those waveforms to the Navy's Littoral Combat Ship LCS mission. Our expertise goes beyond software and firmware development. We also design, build, and test software-defined radios, SDRs, that can be targeted to mission needs for the Navy, Air Force, as well as Special Forces. Recently, we've been developing a novel networked waveform and hardware solution for a proprietary commercial customer. For the past 23 years, GIRD has been solving the military's difficult RF problems, and we have engineers on staff who have been solving these problems for more than 40 years. On a mission or deployment where interference, whether intentional or unintentional, hampers communications, one or more interference excision systems, or IES, may be available to try to address the interference. These IES solutions can live anywhere along the receive processing chain, at RF, IF, and/or digitally after analogs to digital conversion. The question is, what mitigation strategy, in terms of applying one or more IES, should be deployed to address the interference environment? Best here is determined by the resulting performance of the radio, often identified in terms of signal to interference plus noise ratio, or SINR, or in terms of the bit error rate, or BER. It must be recognized that some IES damage or distort the signal of interest while some IES are complementary, such as RF notch filtering followed by additional digital interference mitigation, and others aren't. There is no one-size-fits-all solution for interference mitigation. Typically, the IES are designed to address a certain class of interference problems, for example, certain types of in-band interference, or very high dynamic range out-of-band or adjacent channel interference. So, the challenge is to develop a system that can automatically recognize the interference conditions and select an interference mitigation strategy to optimize the receiver performance. One significant challenge in developing such a solution is that the interference environment can change significantly over time and might change rapidly. So there's a need to detect the changes in an automated fashion and consequently optimize the applied interference mitigation strategy. We also note that with the growing sophistication of our adversaries, the solution needs to be able to identify novel attacks or anomalies and learn as it goes. This could mean reasoning a solution on the fly or simply flagging anomalies and recording the data to study it further so that a new mitigation solution that addresses these interference conditions can be developed. This is where WISDOM comes in. WISDOM is not a program for developing new IES solutions, but rather works with existing and future solutions to optimally deploy a strategy to mitigate interference and allow communications to continue without degradation. Essentially, WISDOM is a smart controller that orchestrates available IES to provide a performance improvement compared to deploying a single IES that is optimized only for specific interference conditions. WISDOM monitors the interference environment and automatically deploys an optimal strategy by selecting from among the available IES to mitigate the interference. It is designed to leverage network capabilities when available, enabling cooperation amongst platforms to share signal awareness and strategies to counter the interference patterns encountered. Wisdom is developed as a software solution that can be deployed on an existing platform or radio system, or can operate as a standalone device that integrates with and complements the radio system. A high-level concept of wisdom is shown in the diagram in the lower right of this slide. Wisdom takes available inputs, including information about the interference environment, signal of interest, or SOI, information about performance of components in the RF chain, and even IQ data, which is used to make a decision on which interference mitigation strategy to apply. Each strategy could correspond to application of one or more IES in specific orders. Wisdom controls not just the switching of the strategies but also provides parameter control of the individual IES, depending on the IES. Performance metrics from the radio can be fed back to Wisdom to inform it of the impact of the IES strategy selection on radio performance. Further, Wisdom can identify anomalies and record samples to storage for offline analysis. It is important to note that these blocks can be either hardware or software, or a combination of the two. Wisdom can run as a standalone hardware device or be integrated as software on another platform or radio. The IES themselves can be software or hardware devices. The core of our approach to Wisdom is based on the use of machine learning. We can think of IES selection as a classification problem, and machine learning enables automatic encoding of decision boundaries which are formed based on training. Thus, it can provide superior performance in complex environments compared to procedural approaches. Interference mitigation strategies are then selected based on information that is input to the trained neural nets. To support training, an extensible characterization and training hardware testbed has been developed on which to train and evaluate the performance of Wisdom. The Wisdom architecture is designed to be flexible to support mission needs or be tailored to the resources of a target platform. It is composed of a collection of microservices in a service-oriented architecture that is extensible to new IES and can be federated across networks when networked operation is available. The Wisdom Phase 2 SBR program is currently in the base period, which runs through the end of the second quarter of 2024. A series of capability demonstrations are being conducted in order to demonstrate the developmental progress of the Wisdom solution, with incremental capabilities being added for each new demonstration. The initial software architecture that supports deployment across platforms with different network and processing capabilities has been developed. The software infrastructure required to support hardware-in-the-loop operation for the IES characterization and training testbed has also been developed, a component of which provides for management for the hardware testing that also serves to provide deployment management to host platforms. Currently, we are working toward the final base period demonstration, which will pull all of the above developments into a hardware testbed demonstration that illustrates the utility of the developed Wisdom system. The design of Wisdom enables a number of key features, advantages, and benefits. Since Wisdom is based on machine learning, optimal interference mitigation strategies can be selected automatically even for complex, dynamic environments. The microservices architecture allows the Wisdom functionality to be decomposed into self-contained components, which not only simplifies development and testing, but also allows Wisdom to be flexibly tailored based on a target platform's capabilities. Networked operation allows multiple Wisdom deployments to share information and learn optimal mitigation strategies in a distributed, federated fashion. This enables collaboration with other systems beyond Wisdom to share lessons learned and innovate solutions to novel scenarios. Anomaly detection lets us store data from novel interference scenarios which can be used for offline learning and to provide information to IES vendors to develop new solutions to the novel interference. Finally, Wisdom is designed to provide integration with third-party IES solutions through a well-defined and comprehensive interface that allows incorporation of the latest IES technologies as new threats evolve over time. The Wisdom technology developed on this SBIR program is initially being targeted to transition through PMW A170 to the WAMS program, which is led by L3 Harris. It is being coordinated as a future upgrade to that system. A future transition path through the same program office would support HF operation in contested and congested environments as part of BFTN. While Wisdom is applied in this SBIR program specifically to interference mitigation, the core Wisdom machine learning engine and software architecture can be applied to any system that can benefit from dynamic control with automated optimal decision-making, such as optimally configuring a system as conditions change or even routing in network congestion. We are looking for partners that have a need or opportunity to apply the Wisdom decision engine to their problems, where transition can take the form of a license of the Wisdom software or integration of a standalone device that runs Wisdom and interfaces to a partner's platform. Thank you for your attention during this presentation of the Wisdom technology we are developing for the Navy. Our contact information is included here for your reference. Please stop by and see us at our booth at Sea Airspace 2024. Jim Caffrey and Bob Hayes would be happy to discuss how to apply GIRD's technologies to solve the DoD's most difficult communications challenges.